Hello everyone. In this session, let us understand a little bit about the architecture of blockchain. By architecture, in this session, I will try to explain what are the different components that make up blockchain. Let's take a look at these components or these terminologies that you might have heard popularly. A node. What is a node? A blockchain node is nothing but a computer which runs some type of code in order to facilitate the blockchain's running. What is a network? A blockchain network is a connection of all of these nodes that are put together and interact in a peer-to-peer fashion. Let's go to the next component. The next component is a block. A block is a basic building block of a blockchain, which when connected together forms the blockchain. And the last but not the least, a distributed ledger. A distributed ledger is nothing but a sort of database that stores all the transactions that are happening across the blockchain. Let's deep dive a little bit into each of these components and understand them better. We already know that a node is a computer, which is a peer or a user. In general, every participant that is participating in a blockchain is nothing but a node. There are different types of node. For example, in the Bitcoin network, that could be a full node that runs the entire blockchain, or there could be a lightweight node that interacts with the full node and is just used to sync the blockchain. Why do we need nodes? And what is this blockchain network built on top of? Nodes are required because blockchain technology is decentralized by nature. And one of the key properties that helps bring this decentralization is the nodes interacting in a peer-to-peer manner rather than everyone interacting with a centralized server. These nodes and the running of these nodes is extremely essential to the security and the integrity of a blockchain network. So, the next time you think about running your own node for a particular network, you're actually contributing to the decentralization of that network by becoming an integral part of the network. To explain the blocks and the distributed ledger, let's take a look at a quick demo. I have with me a popular blockchain demo website called Anders Brown World, where you can play around with how a block and a blockchain looks like. A simple block would have some specific data associated with that block, like a block number, a nonce, which is a number only generated once, a special number used to identify a block, and each block will have some data within it. The data inside the block is nothing but a set of transactions that are clubbed together and put inside one block. Now, the hash that is generated for every block is based on the data that is present inside the data component, or rather, the set of transactions that are put together. So I'm going to finalize this block, and you can see that once a particular block is added to a blockchain, then it is difficult to tamper with the data that is present inside the blockchain. This is one of the features that gives blockchain its characteristic called immutability. Let's take a look at how the blocks are connected in a blockchain. Here you can see that you have several blocks that are connected to each other. But what is the connection string? The connection string between the blocks is the hash that is associated with the blocks themselves. I'm just going to move my video bubble. All right. So you can see that the first ever block, also known as the Genesis block, does not have any previous blocks. So its previous block hash comes up to 0. But there is a hash associated with the data that is present inside each of these blocks. And all of this comes from the transactions, right? So when I mine this, so mining is one of the ways which is a consensus algorithm used in proof of work. Then you have proof of stake, where you are running some other algorithms and adding the block to the blockchain. So when I mine this, that means I'm finalizing this block, right? Now there is a hash that is produced for this block, which is present in the next block as the previous block's hash. And this is how blocks are connected to each other. When I try to tamper with the data of any block, all of the blocks show errors because they are all connected to each other. So for example, let's say if I finalize this one, right? And let's say I finalize the next one as well. It's taking a while. So I added a few transactions. Now, if I try to change anything and say try to tamper some data in the middle, you can see that everything is starting to show red, right? That's because this block is associated with this block and this one with this block and so on, right? That's why it is very difficult to tamper with the data within a blockchain. Now, what is a distributed ledger, right? So the principle of blockchain is that the data is going to be distributed, or the blockchain itself is going to be distributed across different peers, right? That's how we are ensuring that there is complete decentralization in the network. Now, the same blockchain that we saw in the previous tab in the distributed system, the same data will be there, but with multiple peers. So you can see that peer A will have the same block, peer 2 will have the same, peer 1, whatever data is there in peer 1, peer A, peer B, peer C, all of them will have the same data. So you can imagine if there are millions of peers running this node in a peer-to-peer network format, the same data is being replicated everywhere amongst all the peers, right? So this entire data, you can think of it as a ledger, right? Where all the transactions are put together, but transactions are clubbed in the form of blocks. So all the blocks are put together as a blockchain, and this is an entire ledger full of data. This ledger is replicated across peers in the same way, which ensures that nobody can come in and tamper with the ledger easily, right? You can make changes in your local copy, but you can't change the ledger at all the peers, right? This is why there's the concept of 51% attack, that if more than 51% of peers agree to a certain change, to a certain mutability, then that mutability can be considered. So this is where blockchain gains the strength of immutability and transparency, because the data is transparent in a public blockchain and is available amongst all the peers, right? So this is your distributed ledger. The ledger is distributed amongst all the peers. These are some main components of blockchain that these are some key components of blockchain that form the base of what blockchain technology is. There are also certain other things that you will see in other videos like accounts, transactions. So now the next step will be getting deeper into the network and seeing what are the different components within a particular network. So for our Solidity Bootcamp, we are going to be focusing on Ethereum or EVM based protocols. So we are going to look at the Ethereum network first and understand how the different components of that particular network, like accounts, transactions, etc., work. Right? Thank you, folks, and yeah, I'll see you in the next session.